You are looking at the tallest tower ever built, on purpose designed to move 170 floors, 632 meters of steel and glass, and when a typhoon hits, it sways 10 feet by design. This is the Shanghai Tower, and what it took to build it defies logic. But the sway isn't the craziest part. The real story starts 40 meters underground, in soil that swallows skyscrapers whole. Shanghai sits on the Yangtze River Delta, not bedrock, not stone, just centuries of soft river sediment. Every building here sinks a little. Some sink a lot. Early surveys in 2006 showed the ground could shift. The site alone required 3 years of soil analysis. What engineers found should have stopped the project cold. The sediment layer ran 100 meters deep. Nothing solid to anchor to. Nothing firm beneath. And the client wanted the world's second tallest building here, on ground that behaves more like wet clay. The design team, Gensler Architects, faced a fundamental question. How do you plant a skyscraper on nothing? What they came up with hadn't been done before. The foundation answer was brutal and brilliant. Engineers drove 1,079 steel piles into the earth. Each pile 86 meters long, not into rock, into compacted soil, by sheer friction and weight. The piles spread the tower's mass across an enormous area. Together they bear more than 850,000 metric tons. Then came the raft, a 6-meter-thick concrete slab poured across all 1,079 pile heads. That pour alone took 60 hours, non-stop. Over 60,000 cubic meters of concrete in one continuous operation. No joints, no seams, one single monolithic base, the size of a city block. But the foundation was just the start of the impossible. Here's where it gets different from any tower ever built. The Shanghai Tower doesn't go straight up. It rotates. Every floor twists slightly as the building rises. By the time you reach the top, the structure has rotated 120 degrees. This wasn't aesthetic. This was engineering physics. A straight rectangular tower catches full wind load. A twisted form deflects it, sheds turbulence off its curved edges. Wind tunnel testing at Tongji University ran over 500 simulations. The twist reduces wind force by 24%. That means lighter structure, less steel, less cost, less sway, even in a typhoon. But designing a twist created a construction nightmare nobody fully anticipated. Each floor plate is unique. Not one floor in the tower is identical to another. At ground level, the floor is nearly circular, roughly 83 meters across. As it rises and rotates, the shape changes every single level. Carpenters couldn't reuse formwork. Steel fabricators couldn't batch cut identical parts. Every single floor required custom geometry. 128 floors of distinct shapes. Wait until you hear what that did to the schedule. Construction began in November 2008. The original completion target, 2014. But custom geometry on every floor meant slower assembly, constant recalculation, relentless precision checking. The exterior curtain wall alone contained 21,000 glass panels. No two panels cut to the same exact size. Delivery logistics became a puzzle of its own. Glass panels arrived pre-labeled, pre-sequenced, like pieces of a jigsaw the size of a mountain. And the crane work required for this twist, that's a story by itself. Tower cranes can't simply climb straight up a rotating structure. New climbing protocols had to be developed on site. 7 internal climbing cranes operated simultaneously at peak construction. Each crane anchored to the core, repositioned as the floors rose. At one point, crews were pouring concrete for the structural core, while glass installation ran 14 floors below. 3 separate construction teams, working different building zones simultaneously. On a single shift, over 14,000 workers occupied the site. That's more than some small cities. And then the building reached the sky, and a new problem appeared. At roughly 300 meters, wind behavior changes. Vortex shedding, the oscillating force that makes suspension bridges fail, kicks in hard. The twisted form helps, but it doesn't solve everything. What the Shanghai Tower needed was something hanging inside it, a giant pendulum. The tuned mass damper sits on floor 125. It weighs 1,000 metric tons, a 1,000-ton steel sphere suspended on cables floating inside the building. When the tower sways, the damper swings opposite. It absorbs the kinetic energy, cancels the motion, steadies the floors. Without it, occupants on upper floors would feel seasick in moderate winds. With it, a typhoon registers as a minor sway. The pendulum itself required a special installation operation. The sphere arrived in sections, lifted by crane in pieces above the 300-meter mark, assembled in the air, welded in the air, in a shaft with wind speeds at that elevation regularly exceeding 50 kilometers per hour. Workers wore safety harnesses anchored to 3 separate tether points simultaneously. One slip meant a fall of over 300 meters. But the damper wasn't even the most dramatic engineering decision made during construction. Here's the crazy part. The building has 2 skins. Most skyscrapers have one outer wall, one layer of glass facing the city. The Shanghai Tower has 2, an inner structural layer and an outer curved glass skin. Between them, a continuous enclosed atrium space, spiraling upward. This double-skin system runs the full height of the tower. The gap between the skins averages 6 to 10 meters wide. Inside those gaps, 9 sky gardens, stacked vertically, public spaces, cafes, plants, natural light, over 200 meters in the air. The outer skin alone required a structural steel subframe, independent of the main building. A second skeleton wrapped around the first. When engineers modeled the thermal behavior of this double skin, something unexpected showed up. The air trap between the 2 skins acts as an insulation layer. It reduces heating and cooling loads by roughly 21%. An architectural feature became an energy system, entirely by accident. But the weather wasn't done making problems. In 2013, with the tower mid-construction, Typhoon Façade hit Shanghai directly. Wind gusts reached 130 kilometers per hour. The construction site had over 8,000 workers on shift that morning. Evacuation took 4 hours. All 7 cranes had to be locked and weather-vaned, allowed to spin freely into the wind. A locked crane in typhoon conditions can topple. A weather-vane crane survives by facing the storm head-on. When workers returned, inspections took another 36 hours. 300 meters of exposed structure. Not a single weld had cracked. Not one anchor had shifted. The build resumed. By mid-2014, the structural core had reached its full height, 632 meters. But structural completion and building completion are completely different things. Fit out of the interior, mechanical systems, electrical, plumbing, elevators, took another year. The elevator system alone deserved its own engineering project. The Shanghai Tower contains 106 elevators. Among them, the world's fastest at the time of opening. Elevator speed, 20 meters per second. That's over 70 kilometers per hour. Inside a shaft, passengers travel from ground to the observation deck in under 60 seconds, 1 minute from street level to 546 meters above the city. The elevator cabins required special aerodynamic shaping to reduce pressure waves at those speeds. Without the shaping, passengers would feel their ears pop violently at every stop. Pressurization systems in each cab regulate air pressure continuously during travel, the same technology used in commercial aircraft cabins. In an elevator, and the building had one final surprise waiting before opening day. Load testing of the main observation deck, floor 118, required simulated occupancy. Engineers filled the floor with water tanks, replicating the weight of maximum crowd load. Over 300 metric tons of water on a single floor, 600 meters up. The deflection measured 2.4 centimeters. Within tolerance. Within design spec. Exactly as the models predicted. The Shanghai Tower opened officially on October 14, 2016. Construction had taken 8 years and cost roughly $14.8 billion. At opening, it was the world's second tallest building. At 632 meters, it still holds that position today, but the numbers don't fully tell the story. The tower contains more than 300,000 square meters of usable space. Office floors, hotels, retail, sky gardens, a vertical city inside a single structure. The Jing'an Carry Hotel occupies floors 84 through 110. Guests sleeping at 450 meters, looking down on every other building in China. On clear days from the observation deck, visibility stretches 100 kilometers. You can see the curvature of the river delta below, the same soft ground that almost made this impossible. Here's what you're really looking at when you see the Shanghai Tower. A building that shouldn't stand, on ground that shouldn't hold it, twisted to survive the wind, doubled to breathe and insulate, swaying 10 feet on purpose, because rigidity would have destroyed it. 1,079 piles holding 850,000 tons, 1,000-ton pendulum canceling the sky, and 21,000 pieces of glass, none the same, wrapped around a rotating core. They told the engineers the site was unbuildable. They were told the soil was too soft, The wind too powerful, the twist too complex. The tower stands anyway. The next impossible build is already starting. Subscribe to Built Impossible.